David Tong, and I'm a theoretical physicist at the University of Cambridge, and I'd like to tell you a little bit about string theory. So string theory is a speculative and crazy idea for what possibly could be the ultimate law of physics. So to explain what this is, I first need to remind you that physics and nature is organized by scale. So we learn in school that everything is made of molecules, and the molecules are made of atoms, and the atoms are made of nuclei with electrons going around them, and the nuclei are made up of protons and neutrons, and the protons and neutrons have quarks inside them, but after that we don't really know what happens. It could be that there's things inside the quarks, it could be that there's things inside the electrons. The honest answer is we just don't know what the smallest thing is in nature. So the idea of string theory is that wherever this tower of things stops, the ultimate object in nature is a little tiny loop of string that sits inside these particles. And it's the same string that sits inside of all the different particles, but the way the string wobbles and changes tells you which particle you have. So if it wobbles in one way, it looks like an electron. If it wobbles in another way, it looks like a quark. Okay, so this is one of these crazy ideas that physicists come up with every now and then. It turns out, however, that this idea has amazing consequences. So when you manage to write down the equation which describes a little loop of string vibrating in a way that's consistent with quantum mechanics, and this is not an easy equation to write down, it took people about 15 years to understand this equation, but all the effort is worth it. What you find is that this single equation contains within it all the laws of physics that humans have ever discovered in the history of civilization. This means things like the theory of gravity, which is Einstein's theory of gravity that he wrote down in 1915. It means the theory of electricity and magnetism. It means the theory of quarks that we call the strong force, the theory of radioactive decay, which we call the weak nuclear force. Everything that we know about in physics is hidden within this tiny little beautiful equation describing a string. However, there's more. This equation comes with certain baggage as well. For example, one of the things the equation predicts is that there are extra dimensions in our universe. So we know that there are 3 dimensions that we can see. This is this way, and this way. But string theory predicts that there are at least 6 more extra dimensions in the universe that somehow we haven't yet discovered. So the state of string theory at the moment is that we don't know if it's right or wrong. There are lots of people trying to understand the theory, and we hope very much that sometime in the future we'll get experiments that will test whether this is the right theory or the wrong theory of the universe. But at the moment, it's certainly the best bet that we have.